So let's say we have a function f right here, f of x, and we want to find the average value between two given points, in this case, a and b. So a and b, and we want to find the average value of f. Let me write it with green. Average value of f. Okay, so let's break this into equal distances here for x to try to make a Riemann sum out of this. So notice that f average is, if I add f of x1 plus f of x2 plus f of x3 and on, and all the way to f of x sub n, to the last one. And if I divide it by n, f average is almost equals to that. Why is that almost? Because we need to have infinitely many rectangles to make the exact value, to find the exact value of f average. So now I can rewrite this part right here as use the sigma notation from 1 to n f of x sub I times 1 over n. Let me go ahead and go to the next page. Okay, so to make this a Riemann sum, we need to know what is delta x. What do we know about delta x? We know that delta x, change in x, is the last value minus the first value divided by how many rectangles that we have. So delta x equals b minus a all over n. Okay, and if I solve for n, then I have n equals b minus a over delta x. And so 1 over n equals the reciprocal of that, which is delta x over b minus a. Why do I need that? I need to, because I do have 1 over n in here, and I want to substitute that. Okay. So now I can write that f average equals from, and this is n right here, from n equals 1 to n, however many, f of x sub I times delta x over b minus a. Now let me go ahead and go to the next page. So now I'm going to go ahead and let n go to infinity. So f average equals 1 over b minus a from a to b f of x dx. Oh, not too bad. So that's the formula we're going to be using to find f average. So let's have an example. I already have an example ready for us. Okay, here's an example. Find the average value of f of x equals 2x e to the minus x squared on the interval 0 to 2. Okay, well, here's our formula right here. F average equals 1 over b minus a from a to b f of x dx. So f average equals 1 over 2 minus 0, integral from 0 to 2, f of x, 2x e to the minus x squared dx. And of course, here I can simplify that to 1 over 2, 1/2. So f average now equals 1/2 integral 0 to 2, 2x e to the minus x squared dx. Let's continue. So I'm going to go ahead and use a u substitution. If I let u equal to minus x squared, then du equals to negative 2x dx, and dx equals du over minus 2x. I'm showing every step there is. You probably don't have to. All right, since I'm using a u substitution, and this is a definite integral, I'm going to just change the boundaries. I know that when x equals 0, u equals 0, and when x equals 2, u equals -4. So now I'm going to change the boundaries from 0 to -4, and I have 1/2 2x e to the u over times du over -2x. Now remember that I'm supposed to have the bigger number here, smaller number. And 0 is, a -4. I'll replace, I'm going to go ahead and change their position and add a negative out here. So let me go to the next page. So now if I replace the position of -4 and 0, and I'm adding a negative outside, so I have 2x e to the u du over -2x. And so let's see, this 2 can cancel with this 2. This x is canceling x, okay? And I'm left with a negative here, and I have a negative outside. Negative times negative is positive. So now I have f average equals positive 1/2 from -4 to 0 e to the u du. Well, taking integral of that, I have 1/2 integral of e to the u is e to the u from -4 to 0. When I plug in 0 for u, e to the 0 is 1. And when I plug in -4 for u, I have e to the -4. Okay, I'll talk to you soon.